US Physics Olympiad, year 2012, F equal MA, first round. Solutions for all problems you can find below this video in the reference of the description. Problem 1. Consider a dripping faucet where the faucet is 10 centimeters above the sink. The time between drops is such that when one drop hits the sink, one is in the air and another is about to drop. At what height above the sink will the drop in the air be right as the drop hits the sink? Problem number 2. A cannonball is launched with the initial velocity of magnitude v0 over a horizontal surface. At what minimum angle theta minimum above the horizontal should the cannonball be launched so that it rises to a height h, which is larger than the horizontal distance r, that it will travel when it returns to the ground? Problem number 3. An equilateral triangle is sitting on an inclined plane. Friction is too high for it to slide under any circumstances, but if the plane is sloped enough, it can topple down the hill. What angle incline is necessary for it to start toppling? US Physics Olympiad, year 2012, F equal MA, first round. Problem 4. The particle at rest explodes into 3 particles of equal mass in the absence of external forces. 2 particles emerge at a right angle to each other with an equal speed v. What is the speed of the third particle? Problem number 5. A 12 kg block moving east at 4 meters per second collides head-on with a 6 kg block that is moving west at 2 meters per second. The 2 blocks move together after the collision. What is the loss in kinetic energy in this collision? Problems number 6 and 7. The following information applies to questions 6 and 7. 2 cannons are arranged vertically with the lower cannon pointing upward towards the upper cannon and the upper cannon pointing downward towards the lower cannon, 200 meters above the lower cannon. Simultaneously they both fire. The muzzle velocity of the lower cannon is 25 meters per second and the muzzle velocity of the upper cannon is 55 meters per second. Question number 6. How long after the cannon's fire do the projectiles collide? And question 7. How far beneath the top cannon do the projectiles collide? Problem number 8. A block of mass m equal 3 kg is moving on a horizontal surface towards a massless spring with the spring constant K equal 80 Newton per meter. The coefficient of kinetic friction between the block and the surface is mu K equal 0.5. The block has a speed of v equal 2 meters per second when it first comes in contact with the spring. How far will the spring be compressed? Problem number 9. A uniform spherical planet has a radius r and the acceleration due to gravity at its surface is g. What is the escape velocity of a particle from the planet's surface? Problem number 10. 4 objects are placed at rest at the top of an inclined plane and allowed to roll without slipping to the bottom in the absence of rolling resistance and air resistance. Object A is a solid brass ball of diameter d. Object B is a solid brass ball of diameter 2d. Object C is a hollow brass sphere of diameter d. Object D is a solid aluminum ball of diameter d. Aluminum is less dense than brass. The balls are placed so that their centers of mass all travel the same distance. In each case, the time of motion t is measured. Which of the following statements is correct? US Physics Olympiad, year 2012, F equal MA. First round. Problem 11. Solution for this problem you can find below this video in the reference of the description. As shown below, Lily is using the rope through a fixed pulley to move a box with a constant speed v. The kinetic friction coefficient between the box and the ground is μ less than 1. Assume that the fixed pulley is massless and there is no friction between the rope and the fixed pulley. Then, while the box is moving, which of the following statements is correct? US Physics Olympiad, year 2012, F equal MA, first round. Problem number 12. Solution for this problem you can find below this video in the reference of the description. A rigid hoop can rotate about the center. Two massless strings are attached to the hoop, one at A, the other at B. These strings are tied together at the center on the hoop at O, and the weight G is suspended from that point. The strings have a fixed length regardless of the tension, and the weight G is only supported by the strings. Originally OA is horizontal. Now the outer hoop will start to slowly rotate 90 degrees clockwise until OA will become vertical, while keeping the angle between the strings constant and keeping the object static. Which of the following statements about the tensions T1 and T2 in the two strings is correct? Problem number 13. Shown below is a graph of the x component of force versus position for a mass equal 4 kg cart constrained to move in one dimension on the x-axis. At x equals 0, the cart has a velocity of -3 meters per second in the negative direction. Which of the following is closest to the maximum speed of the cart? US Physics Olympiad, year 2012, F equal MA, first round. Problem 14. Solution for this problem you can find below this video on the reference of the description. A uniform cylinder of radius A originally has a weight of 18 newtons. Half-10 of Fx cylinder hole at 2/5A was drilled through it. It weighs 65 newtons. The axes of the two cylinders are parallel and their centers are at the same height. A force T is applied to the top of the cylinder horizontally. In order to keep the cylinder at rest, the magnitude of the force is closest to. Problem number 15. A car of mass M has an engine that provides a constant power output P. Assuming no friction, what is the maximum constant speed V maximum that this car can drive up a long incline that makes an angle theta with the horizontal. Problem number 16. Inside a cart that is accelerating horizontally at acceleration a, there is a block of mass m connected to two light springs of force constants k1 and k2. The block can move without friction horizontally. Find the vibrational frequency of the block. US Physics Olympiad, year 2012. F equal MA, first round. Problem number 17. Shown below is a log by log plot for the data collected of amplitude and the period of oscillation for certain nonlinear oscillator. According to the data, the relationship between period t and amplitude a is best given by such equations. Problem number 18. A mass hangs from the ceiling of a box by an idle spring. With the box held fixed, the mass is given an initial velocity and oscillates with a purely vertical motion. When the mass reaches the lowest point of its motion, the box is released and allowed to fall. To an observer inside the box, which of the following quantities does not change when the box is released? Ignore higher resistance. Problem number 19. A 1500 watt motor is used to pump water a vertical height of 2 meters out of a flooded basement through a cylindrical pipe. The water is ejected through the end of the pipe at a speed of 2.5 meters per second. Ignore friction and assuming that all of the energy of the motor goes to the water, which of the following is closest to the radius of the pipe. The density of water is ρ equal 1000 kilograms per cubic meter. US Physics Olympiad, year 2012. F equal MA, first round. Problem 20. Solution for this problem you can find below this video on the description reference. A container of water is sitting on a scale. Originally, the scale reads M1 equal 45 kg. A block of wood is suspended from a second scale. Originally, the scale reads M2 equal 12 kg. The density of wood is 0.6 gram per square centimeter. The density of the water is 1 gram per square centimeter. The block of wood is lowered into the water until half of the block is beneath the scale. What is the resulting reading of the scales? Problem number 21. A spring system is set up as follows. A platform with a weight of 10 newtons is on the top of two strings, each with a spring constant 75 newton per meter. On top of the platform is a third spring with a spring constant 75 newtons per meter. If a ball with a weight of 5 newtons is then fastened to the top of the third spring and then slowly lowered, by how much does the height of the spring system change? Problem number 22. The softest audible sound has an intensity of I0 equal 10 power negative 12 watt per meter square. In terms of the fundamental units of kilograms, meters and seconds, this is equivalent to which one? We have 5 choices. American Physics Olympiad, year 2012, F equal MA. First round. Problem 23. Which of the following sets of equipment cannot be used to measure the local value of the acceleration due to gravity, g? There are 5 different sets. Problem 24. 3-point masses M are attached together by identical springs. When placed at rest on a horizontal surface, the masses form a triangle with the side length L. When the assembly is rotated about its center at angular velocity omega, the masses form a triangle with a side length 2L. What is the spring constant K of the springs? Problem number 25. Consider the 2 orbits around the Sun shown below. Orbit P is circular with radius r. Orbit Q is elliptical such that the furthest point P is between 2r and 3r. And the nearest point A is between r over 3 and r over 2. Consider the magnitudes of the velocities of the circular orbit Vc, the velocity of the comet in the elliptical orbit at the furthest point Vb, and the velocity of the comet in the elliptical orbit at the nearest point Va. Which of the following rankings is correct?